Hey everybody, welcome back to today's edition. We're simplifying radicals. We're going to use our little thing over here to help us simplify radicals, okay? So here's the idea. I have a number and I have another number. If I multiply them together underneath this square root, it's still just that number underneath the square root. If that doesn't make sense, let's look at a number. In other words, square root of 4 and square root of 9, I can rewrite 4 times 9 is 36 and put it underneath all one radical. Okay? What we're going to focus on mainly is breaking them apart. In other words, if I have something like 36, I want to break it down to factors like 4 times 9 because that gives me 36, and then we'll break it down to something even smaller. So let's take a look. So the first thing we want to do is we want to check to see, is the square root of 12 a nice number? And what you notice is that it's poopy, right? It's poopy. And so because it's poopy and I can't change it to anything, I got to break it down to factors. So what I'm going to do is I'm going to look for 12. I don't see 12 in this list over here on this side. All right. The next smallest number is 9. So can I take 12 and divide it by 9? No, that's a poopy number. Let's try 4. If I divide it by 4 is 3. So that's good because now I'm going to rewrite this as the square root of 4 times the square root of 3. And the reason why I'm writing it like that is because the square root of 4 is 2. So now this part becomes 2. And then the square root of 3, we can check that, but that's just going to be something poopy. And I can't break this down to anything else, right? That's a poopy number, so we don't like poopy numbers. So here's what we're going to say. Square root 12 and 2 root 3 are the same poopy number. Do you agree? Those are the same numbers there. So this is simplified as 2 square root 3. That would be my answer. All right, next problem we try is square root 27. Is that a perfect square? 27. No, it's poopy. Poopy. So we have to break it into factors. Is 25, so start with 25. Is 27 divided by 5, is that even? 27 divided by 25. No. So let's try 16. All right, so let's go 16. No, that's poopy. Let's try 9. Hey, 9 works. So 9, square root of 9, times the square root of 3. Okay? And then, if we look over here, we notice that the square root of 9 is equal to 3. So we're factoring out the square roots. And we already know the square root of 3. I can't do anything more to that. So it's just going to stay as a remainder of 3 root 3. So now the question is square root 27 the same as 3 root 3? Hey, they're both the same poopy decimal. Cool. That means that this is simplified correctly. All right. You always want to check, is the number a perfect square? Because if it is, then you're done. That's poopy. So let's start. What is the biggest number that's underneath 192? 169. So let's try this. We go 192 divided by 169. That's poopy. So let's divide it by 144. That's poopy. So we divide it by 121. That's poopy. We divide it by 100. That's poopy. We divide it by 81. That's poopy. We divide it by 64. Hey, there we go. So that's a nice 64 times the square root of 3. Oh, all these square roots of 3s. And we know the square root of 64 is 8. Say there. So now this becomes 8 times the square root of 3. So the goal is to always keep the smallest number possible in here. Okay? So I can simplify radicals by breaking apart radicals by perfect squares. Breaking apart radicals by perfect squares. All right, so let's try a couple more. Square root 175 175. Poopy. So let's try the square root. Let's see, 175. Let's see, 169. So let's do 175 divided by the next biggest perfect square. No. How about the next biggest perfect square? 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 No. 36? No. 25? Hey, 25! So the square root of 175 is the square root of 25 times the square root of 7. Okay? And the square root of 25 is 5. And the square root of 7, the only thing that gives you 7 is 1 times 7, so there's nothing more to do. So 5 root 7. 5 root 7 is the same poopy decimal as square root 175. All right, let's try the next one. 240. So 240, let's see. Square root 240. Poopy. All right, so let's take the next biggest square root, so 225. So we're going to take 240 divided by 225. Nope. 196. Nope. 169. Nope. 144. Nope. 121. Nope. 100. Nope. 81. Nope. 64. Nope. 49. Nope. 36. Nope. 25. Nope. 16. Hey, 16. 16 times 15. Cool. So, square root of 16 is 4. The square root of 15 is just 15. Why? Because here's what we're thinking. I can break the square root of 15 down to the square root of 3 and the square root of 5. But the thing is that 3 and 5, they don't break down to anything. So I'm just going to keep it as 4 root 15. That is the smallest number possible in there. All right, so let's try the next one. 208. Let's take a perfect square. Let's see. Is 208 the perfect square? 208. No, it's not a perfect square. All right, so let's take 208 and start dividing it by perfect squares. So 208 divided by 196, 169, 144, 121, 100, 81, 64, 49, 25, 16. Hey, 16 and 13. All right, so square root 16, square root 13. All right. Square root 16 we know to turn into 4. And then the square root of 13 just stays as the square root of 13. That is the smallest possible thing going on there. All right, guys, thanks for checking out this video. We'll catch you next time. Word.